Hello everyone and welcome to this talk called Finding a Lost Song with Node.js and Async Iterators. So before getting started, I always like to share my slides, so you can already get the slides online. You can go to this link, you can scan the QR code, and the reason why I like to do that is because you're gonna find a number of code examples and links, so I think it's just gonna be easier for you to grab the slides and check them out after the talk. Okay, let's get started then. So I don't know if you ever get that feeling that a random song just pops into your head and you cannot shake it anymore. Basically, it doesn't matter what you do every day, it keeps coming back to you. And the only thing you want to do at that point is just listen to that song. But what if you cannot really remember the details of the song, like the author, the title, like how do we find the song? There must be a way to remember, right? And today I want to tell you the story of how I solved this problem using a number of different technologies like Last.fm API, Node.js, and async iterators. And hopefully we're gonna be learning something together while I tell you this story. But before we do that, let me introduce myself very quickly. My name is Luciano, I am Italian, even though I live in Ireland, Dublin. I am a senior architect at Theorem, and I am the co-author of this book called Node.js Design Patterns. This book is actually something that makes me really proud. It's, I think, one of the best achievements of my career, and the book tries to cover all the topics that I think are important if you are a JavaScript or a Node.js developer and you want to improve your knowledge so that you can confidently ship code into production. So check it out. If you like the book, definitely let me know. I'm always looking for feedback. Other than that, feel free to connect with me. You can find me in the most common channels, Twitter, GitHub. I even have a Twitch account, a blog, so don't be shy. Feel free to connect. I always love to make new friends. If you're curious to know more about the company that I work for, it is called Theorem. It's a company based in Ireland, even though we work remote, so worldwide. And what we do, we are a consultant company. We are specialized on AWS and serverless, and we help essentially other companies to get the best out of these technologies. So if this is something that interests you, again, don't be shy, let's get in touch. And we are also hiring, so if you are interested in working with us, that's definitely a conversation we can have. Okay, so back to the story. There was this song in my mind. And there was this one detail other than just the tune of the song that I could remember, that the word dark was probably in the title. So I only had this kind of indication, and that drove me to start to do some search online and see, okay, can I really find the song by just remembering this one keyword? And the first thing that I did was I opened my Spotify, I put the word dark in the search bar, and this is what I got, like 1,000 songs, and you cannot even scroll after 1,000 songs. So I couldn't find a song in there, and I was very disappointed that, I couldn't remember anything else useful to narrow down the search. So at that point, I remember that there is a website that I really like and I have been using for years that is called Last.fm. And if you don't know Last.fm, it's basically like a social network for people who love music. And the one main feature that Last.fm does, which is really cool in my opinion, is that you can use a software called Scrobbler that integrates with most media players. And that software allows you to basically record the titles of all the songs that you have been listening to over time. And that basically creates a database for you that you can consult later, but also that database can be used by Last.fm to give you advices about new interesting music that is similar to your taste, or concerts, or everything related to your musical taste that you might like. So I've been using Last.fm for a while, and I just thought, okay, that song is gonna be there somewhere, right? I've been listening to this song some time ago. It must be there in my profile. So I went to my profile and I immediately realized, okay, I have been scrolling since 12 February 2007, so a good number of years now. And I do have more than 250,000 records in my profile. So again, definitely the song must be there, but there is a lot of data to navigate through, right? And I started to just look at the history. Like you can go from like today back to your history. And of course that wasn't an easy task because there were like more than 5,000 pages. Also there is no search functionality, so that would have taken me a while to really go through the entire history just to find all the songs that contain the word dark in the title. Of course, being a software engineer, the first thing that I thought was, okay, I can just write a crawler. This crawler can navigate this pagination for me, and it's just gonna look up the table and filter out all the songs that contain the word dark. But before I started to do that, I realized, okay, thankfully there is an API, so maybe I don't really need to write a crawler for this. Maybe I can just use the API. And actually the API is quite good. Yes, it's a little bit old. You can see a little bit of XML here and there, but thankfully you don't have to use the XML. There is even a JSON version. But at the end of the day, the API, even though it's not perfectly RESTful, is quite useful for this task. So I found this specific endpoint, even though it looks more like a RPC style of API. And this API allows me to basically get the most recent tracks, but then you can also go in a paginated fashion. You can go back in history, and from the most recent page, you can navigate your entire history. So that seemed like a good candidate for what I wanted to achieve. So the first thing that I did, I just used curl and ran a very quick test just to see, okay, is this API really working? What is the shape of the output? Is my API key valid? And all these kind of things. So I did run this curl, and this is basically what I got. I got a successful response, and I could start to see the shape of the response. So it's a JSON object. In the first part, you have like attributes that are going to tell you, okay, this is page 1 out of like 5,000 and more pages. And track is basically an array that gives you all the tracks that are in that specific page. So that's basically a good starting point. Now what I wanted to do is, okay, let's convert this call to JavaScript so I have a little bit more control in navigating through the pages and filtering the data. So how do we do that? Very simple. We can just use query string and Axios to build the URL and to basically do the HTTP request, and then we get the response, and at that point we just console log the response. So if we look at the output of this, it's quite similar to the previous one, except that of course JavaScript is adding a little bit more formatting. For instance, all the tracks are not automatically displayed there because JavaScript is being smart and just showing us a little bit of information without going too much deep into the response object. But this is good enough for now. So let's again have a closer look at this to understand better the shape of the data. So the first part is metadata header, where basically we see that we are getting a paginated response. There are 50 tracks per page, and there are more than 5,000 pages. Then the second bit is that there is an array of tracks. And the first thing that I noticed almost incidentally was, okay, this doesn't seem like 50 results. Like we are getting in the metadata that there are 50 elements per page, but in reality we are seeing 51 here. So that there was something fishy there, but don't worry too much about that right now. We'll discover what's happening there in a second. The interesting question now is, okay, we are getting a page. How do we go to the next page, right? So we can continue exploring the data, right? And thankfully, this API actually supports that out of the box. You can just pass an additional query string parameter called page. By default is 1. So by default, you get the first page, and then you can continue with the second page, third page, and so on until you visit all the pages. So how do we introduce this additional logic into our example? Actually quite simple. We start by creating a variable called page equal 1, because by default we want to start from the first page. Then we need to start doing a loop, right? We need to iterate until we visit the very last page. So for now, we're just going to have a simple while true loop, and then we are going to break eventually when we see that we are visiting the last page. Initially, keep in mind that we don't really know how many pages we have to explore. So that's why we are using a while rather than a for loop. Okay, so the only change when we build a URL is that we also want to pass the page query string parameter. So the first time this is going to be page equal 1, and then we're going to go page equal 2, equal 3, and so on. And now finally, the additional bit is after we get the response for the current page, we need to do two things. The first thing is to make sure that this is not the last page. If it is the last page, we need to break. If it's not the last page, we just need to increase the counter, and then in the next iteration of the loop, we are going to get the second page, the third page, and so on. So if we run this code, we should see something like this, and you can notice that in this position that the page number is increasing. So all seems good, but now let's look again at the tracks. Let's try to get a little bit more detail on the type of records that we get. What kind of fields do we have? How can we get the title of the song so that later on we can start to do filtering on this data? And the easiest way to do that is, of course, to do another for loop for every single page, and for every track we just want to log a little bit of information, like the date when that song was, did I listen to that song, the name of the artist, and the name of the song. So if we do that, we should see something like this, where basically, the first thing you should notice is that I did a little bit of cheating here, because the page size here is 10, just to make it simpler for me to visualize the different pages. But yeah, this is just an optimization here for me to explain what was my train of thought there. So other than that, the interesting thing that you probably are gonna noticing already is that for every single page, the first element in the page is telling us undefined, right? In terms of timestamp. And the other interesting thing is that if you look at page 2 and page 3 here, it is the same song there. So I was a little bit suspicious, like, okay, this doesn't look right. And it turns out that the first song you get for every page, if you are listening to a song right now, or like as you run the API request, you will get a special entry at the first record of every page, which is like the now listening to song. So this song will eventually be moved into the history of songs, but only when you finish to listen to that song, basically. So this is an interesting feature, not really expected, and this also explains why we were trying to get 50 elements per page in the previous API call, but we were getting 51. Here we are trying to get 10 and we are getting 11. So this is because Last.fm just tries to give you some additional information, and you can decide whether you want to look at the current song or not, or just disregard it. And the other interesting thing is that if you look between page 1 and page 2, we have the same song repeated. And it is not just that I was listening to that song twice, it is literally the same record, because you can see that the timestamp is literally the same. And this is a problem, and basically I like to call this problem the sliding windows problem. And let me try to explain what's happening here. So keep in mind that I'm trying to navigate the history of all the songs, and at the same time I'm listening to more songs. So this is kind of a moving target. As I look at the data is changing. So that's why we bump into this problem. And we can try to visualize the problem like this. So there is a sequence of tracks that are ordered from the newest to the oldest. And basically we are trying to explore all this data by dividing it in pages. So in this example, we have, let's say, 5 records in page 1 and 5 records in page 2. Now, after some time, what happens is that I finish to listen to a new song, and this song is basically prepended at the very beginning of all this data. So it's going to go more or less here, right? So if we try to look at a paginated view of all these records now, it's going to look more or less like this. So it's like everything is shifting on the left. So page 1 is now including the new track, and page 2 is going to include as the first track what was the last track from the previous pagination that we did, right? So you can see that the blue element here ended up in the second page in the second case, right? So basically it moved from page 1 to page 2 over time. And this is a problem that we need to resolve, because this is why we were seeing that song being repeated, because while I was going through the pagination, a new record was introduced, so that song was suddenly moved from page 1 to page 2. So I did end up looking at two different versions of the pagination while I was going through the data. Now, this might not be a big deal, meaning for what I wanted to achieve is I would just got a little bit more duplicated data and then I would have to filter it out. But in reality, there is a way to fix this and solve it in a quite elegant way. So let's try to do that. And one interesting approach is to use timestamps as a way to navigate through the pages. And very interesting, this API offers a way to limit the time window. So for instance, we can use the parameter called to, and that parameter called to indicates the end of a timestamp, meaning that basically we want to start to get data from a specific point in time or to a specific point in time. You can see that we have both from and to. So let's see how this can work for us so that we can implement time-based windows. So again, let's visualize all our tracks from newest to oldest. And basically, again, we have page 1. So now after we fetch page 1, what we can do is to look at the last element in page 1. We are going to call this T1. And then what we can do in order to issue the next request and try to get data for what we can call page 2 is just to say, okay, now I want everything that is starting from T1. So basically we say everything that is before T1, because keep in mind that the data is in reverse, in reverse time order. So at this point we are saying, okay, the page 2 is not page 2 anymore, but it's page 1 to T1 in time, right? And we can do the same again. And basically in this page, we look at the last element, we get the timestamp, we're going to call this T2, and the next pagination is going to be, okay, everything before T2, which basically means page 1 to T2. And when are we finished? Basically, we are finished when we see that we get an empty page, because at that point there is no more data to explore. So why this is advantageous? Because if the data is changing over time, we are just gonna end up ignoring the new data, and we are looking at a snapshot in time, and we keep traversing using the time reference rather than the page number reference. Okay, I hope that all of that makes sense. Let's see how we can convert that into code. So this time, rather than using page, we are going to be using this variable called to, which is going to store the timestamp. Initially, it's going to be undefined. So the first time, we don't even include that in the query string parameter. In the next iteration, we are going to be calculating the to. So from the second request on, we are going to be having a value. So that value is going to be part of the URL. Okay, then we need to do this, where basically we need to check if it is the last page. And a way to do that is to basically look at the total pages. And if that value is 0, that basically means if 0 or 1, that basically means that we are looking at the last page or we ended up in an empty page. So at that point, we can just break. And now we need to calculate the value for that too. So basically, we look at the last song in this specific page, and we take the timestamp of that last song. And this will keep iterating until we get to the very last page. Okay, so now if we look at our response again, and I added a little bit more information here, what we can see is basically the track, the timestamp of the last track is basically what we use to get to the next page. So this seems to work as we wanted. And also you can see that there is no more duplication between pages. So now it seems to work much better. We still have that undefined because I'm still listening to songs as we go through the pages, but we can just ignore the first record if we don't care about the currently played track. Okay, now we have a working solution. Can we generalize it? And by that I mean, okay, I want to solve a very specific problem, but maybe since I figure out a way to go through all this data, I can create like a library, and this library will allow other people to just consume their stream from Last.fm and do whatever they want with the data. So the first question I had is, okay, we implemented only this iteration in a very rough way. How do we expose this functionality to a potential third-party user in a way that it looks idiomatic, it looks easy to use? And basically, I started to think about all the different ways I knew to expose this kind of information. And the idea was like, okay, you are going to be getting pages over time, and then you want to give access to the user of the library to that data in that page. And at the same time, you want to give them a way to keep going through the other pages when they're done. So a simple approach could be a callback-based approach, where basically we can create a reader object, and then this reader object will have a method called read pages, and then in that method you need to pass two callbacks, one to basically react every time there is a new page available, and another one that allows you to handle errors or maybe a completion itself. So this is a very traditional approach, very callback based, so you end up passing callbacks to react to data appearing over time. Okay, it's not too bad, but let's see if there are other alternatives. Another alternative, which is also very common in Node.js, is event emitter. So basically you create a new reader, you call read to start to consume the data, and then you attach event listeners. And for instance, we can say, okay, I want to listen for the event page, which is gonna happen every time there is a new page available. And I also want to listen for the event completed and react to that. Notice here that I'm including potential errors in the completed event. I could have also considered the case where error would be another independent event, and we would listen to errors as well if we wanted to manage errors. Okay, again, that approach is fine, but let's see other alternatives. Okay, let's use streams. If you know me, I really love Node.js streams, so why not considering that option as well. So with a stream, what you generally do, you create a stream object. In this case would be like a readable stream that would read the tracks from Last.fm API, and then we can pipe this stream to something else, like a transform stream or a writable stream, and then we can listen to events like end or error to figure out when the stream is completed or if there was any error. Again, that's fine, but when you use streams and you start to have complicated pipelines with multiple steps, like for instance here we want to process the data, it's much better to use the pipeline operator. So we can create a reader, we can create a specific stream to process the data, and then we use pipeline to concatenate the readable stream with the processing stream, and then we can also handle completion and errors in a way that is much more streamlined. So this will be the approach that I recommend if we want to go with streams. But then there is another one that is async iterators. So with async iterators, if you ever use them, you have this very nice syntax that looks almost like a regular for loop. You just have this special await keyword, and you can say for every page on this reader, do something, right? And that looks very easy to read, and you can put this specific snippet of code in your application, and the code, when you read it, is going to look very sequential. Like you don't have to think too much about the order of different events, callbacks maybe happening at certain point in times. This looks, the way you write it, it looks more or less the way it's going to be executed. So this seems interesting. So maybe we want to go with this approach, but before we do that, let's also consider that we might want to manage errors. So the interesting thing about async iterators is that the error handling is unified. You can use a try-catch to catch any special error that is happening asynchronously as much as error that are happening synchronously. So that's another reason to like the async iteration approach, because you can just use a try-catch and that will help you out to catch any type of error happening in that piece of code. So how can we build an async iterator, I suppose, is the next question, right? We are deciding right now, okay, we're going to implement this API, this library as an async iterator that other people can use. How do we do that? And to understand how we do that, we need to introduce iteration protocols in JavaScript. And iteration protocols start with the iterator protocol. And basically we say that an object in JavaScript is an iterator if that object has a next method, and every time that we call that next method, it returns another object with two keys. One key is called done, and it's a boolean, so it can be true or false, and another key, it's a value. And basically the idea is that we can keep calling next to see, is there a next element, is there a next element, and the response is going to give us this wrapper object that is going to tell us, are we done, yes or no, and if we are not done, this is the current value. So let's see a very simple example. Let's say that we want to implement a countdown. Countdown, it will be like a very simple object. We can give it a starting integer, let's say 10, and then we can iterate, and we expect that at every step of the iteration we get 10, 9, 8, and so on until we reach 0. So how do we implement the iterator protocol for a countdown? So it's actually very simple. Here we have a factory function where we get the configuration. In this case, we just want to know what is the starting point. So from is going to tell us I want to start from a number, for instance, 10. So the first thing that we do is we store that information into nextval, and then we start to implement the iterator protocol. So remember that we say the iterator protocol means it's an object, so we start to return an object. This object needs to implement a method called next, doesn't accept any argument, so it's just a function called next, and this function needs to return a specific type of object. And here we have two cases. Either we are done when we reach 0, so we just return done true, or we are still iterating, and in this case the object contains done false and value the current value. Notice that we are also decreasing the value here, so the next loop is basically, the next time we call next, we are basically decreasing the value until we get to 0. I hope this makes sense, but let's see how we use it. So we create the countdown, we create the countdown object first, and we say, okay, I want to start from 3, and then we keep calling countdown.next. And you can see that if we log the value of countdown.next, we initially see done false, the value is 3, then done false, the value is 2, and so on until we get to done false, the value is 0. And the next time we call that, we get done true. And at that point, we can keep calling next, but we know we are not going to get any meaningful value out of it. Another interesting thing is that generator functions produce iterators. So we could also do the same thing by using a generator. If you have never seen generators, don't worry, I'm going to try to explain this very quickly. A generator is basically a special type of function, or if you want, a function with superpowers, and you give the superpower by putting an asterisk just in front of the name of the function. And when you put this asterisk, what is going to happen is that you can use this special keyword inside the function that is called yield. And yield allows you to actually yield or provide values back to the caller. It doesn't do just that, so it's not like an alternative, just like an alias for return. It does a little bit more than just returning a value. And what it does is it's going to remember exactly where you did yield that specific value, and the next time you're going to call this function is going to resume the computation from that point. So basically the way that this code works is that we are starting a for loop, and this for loop goes from the number from, let's say 10 to 0. So the first time is going to yield 10, so the receiver is going to receive this number 10. At the next iteration is going to remember that I did yield at this point and the value was 10. Now I just need to continue the code from there. I'm going to repeat the loop, and now the value is going to be decreased by 1. So the value is going to be 9, it's going to be yield. Again, the state of this function is going to be frozen, and we keep iterating as many times as we want until eventually we reach 0, and at that point the function is going to complete, and at that point the generator is exhausted. How do we use this? The code is exactly the same. So you can see that implementation is perfectly equivalent with our original implementation. So in a way, you can see generators as a syntactic sugar to create iterators. But there is another interesting protocol that is called the iterable protocol. And let's see how it is defined. In JavaScript, an object is an iterable if it implements the @ iterator, which we'll see in a second what it means. And this @ iterator is a method that doesn't require any argument, and it returns an iterator. So you can see that the iterable protocol is connected with the iterator protocol. And the way I like to think about this is that an iterator is simply an object that allows you to move through the data, because you can call next every time you want to move. Instead, iterable is more of a higher level concept. Is when you have an object that contains data and you want to get, and you know you can get this data in an iterative fashion, and you just want to tell this object, can you give me an iterator so that I can start to consume this data? So this is how you can see the difference between iterable and iterator. And in a way, iterable is a little bit of more abstract concept. It's like just telling you, yes, you can iterate over a given object, but to iterate over, you need to get an iterator first. Okay, so how do we implement the iterable protocol, again by staying with the countdown example? So in this case, very simple, the code is almost the same. The only difference is that rather than just returning an object with next, we return an object that implements that @ iterator method. And @ iterator is basically a way to, you can define that @ by using symbol.iterator. So we are basically saying this special function called symbol.iterator is what is gonna return an iterator for this specific object. So the countdown object is iterable because it can return an iterator. And the iterator is basically the same code as before. It's just an object with a next function, and that next function is going to return another object that is done, true or false, and a value. So again, we are just adding an additional level of wrapping to mark that specific object as iterable. And again, this is something we can do with generators, so this code here will be perfectly equivalent. And you might ask now, okay, we did all this additional work, all this additional wrapping, but what is the advantage of doing that? Why don't we just use just the plain iterator? And the reason why is that if an object is iterable, then you can use a bunch of additional syntactic sugar or helpers if you want. For instance, you can use the for-of, and here you can see that if we use the for-of, we can immediately access the value of every single iteration without having to deal with the intermediate object. We don't have to check if done is true to stop, because the loop is going to stop automatically. So this is just convenience. Like it's good to implement the iterable protocol because you get a lot more integration with other parts of the language. Another useful example, which I'm not showing here, is that you could also use the spread operator. So if an object is iterable, you can say ... that object and spread all the values, for instance, into an array or a function call. So another additional reason for using iterables rather than just plain iterators. Okay, so now all this stuff is synchronous, but our use case is asynchronous. So between one page and another, we need to make an HTTP request, and we know that that operation is asynchronous. So we need to basically do all this iteration, but between one element and another, we need to perform an asynchronous request and wait for that request to be finished before we can continue to the next iteration. Is there a way to do that? Actually, yes, because all these protocols that we explored, they have an asynchronous equivalent. And these are called the async, iterator, and iterable protocols. So let's see the difference, for instance, for async iterator. Async iterator is actually very simple. Like, let's see the difference is literally that, again, it's an object with a next method, but this time the next method doesn't just return a plain object, but returns a promise that will resolve to an object. And of course, the object will be having keys done and value. So the only difference here, again, is just that rather than returning when we call next, rather than returning an object straight away, we return a promise, and then eventually that promise will resolve to an object with the keys done and value. So this way we can basically say with a promise, I can do any asynchronous operation before I'm ready to give you the information about the next iteration. So you just start an asynchronous process, an asynchronous computation, let's say, and you don't really know if, for instance, you are at the last page until that promise is resolved. So that allows you to do call to databases, check in the file system, have network communication, API requests, and so on. So you can see how returning a promise allows you to introduce asynchronous behavior in the iteration. And if we want to implement this, it's actually very simple. Again, the countdown example, now we are adding a delay. So before one item and another, we wait an arbitrary amount of time, which by default is 1 second. So how do we return a promise? The easiest way is we just mark the next function as async. And then the next thing that we do, we wait for that timeout. So we wait 1 second, for example. And at that point, we can return the value, either done true or done false, and the specific value. So you can see how we are converting our timer into, or our countdown timer into an asynchronous version where we are actually waiting for 1 second between an element and another. And the way we use it is actually the same as before. The only difference is that because next is returning a promise, of course we need to await that promise in order to be able to access the data. Okay, if we run this example, we should see something like this. So you can see that it takes a little bit of time between one element and another, but then the element is the same response as we saw for a synchronous iterator. And again, we can also use generators. And interesting enough, generators can also be asynchronous. So now we are creating a function that has two special superpowers. One is the asterisk, which makes it a generator and allows us to use yield. And the other one is async, which allows us to use the keyword await. So here we can both await for the timeout to finish and then yield. And we get all the benefits from async functions and generator functions. Now the last piece of information we need to complete our task is to explore the async iterable protocol. And again, it's very similar to the synchronous counterpart. The only difference is that rather than returning an iterator, we want to return an async iterator. And of course, the name of the method changes as well. So you can see here we have to use symbol.async iterator, and then that function needs to return an async iterator. And here we are using as a shortcut the generator version of that. So if we run this code, you can see that we can use for await because now it's an async iterator. You can see that we get the value straight away. We get 3, 2, 1, 0, and the loop is going to finish automatically. We don't need to look for the done variable to decide when to stop. Okay, perfect. So now we know exactly how to create custom async iterable and how to use them. So why don't we build our library using these concepts? And this actually is simpler than I anticipated initially, because now that we understand the protocol, we know that the protocol is easy to implement. For instance, here we are creating a last.fm recent tracks. So this is going to be our iterable object. But how do we say that this object is actually an async iterable? We implement the async iterable protocol. So we need to expose this specific function. And this function is a generator function. And when we do the HTTP request, at this point, we can yield all the tracks. So at that point, we are giving the user the opportunity to intercept all the current tracks from the current page and do something with them. They can just filter the data, they can store it in a database, they can save it in a CSV file. At this point, the user receives all the tracks for the current page, and they can do whatever we want with them. And finally, everything is the same. So we check if this is the last page and we calculate the next page. So this loop is going to keep going. Every time the asynchronous iterator is used, you access the current tracks, and it keeps going until all the pages are visited. So how do we use this? Now it becomes very, very easy. We just need to instantiate a new recent tracks. We pass our current API key and the username. And at that point, we can just do a for await. And in that for loop, basically, we are going to get every single page. And if you see the screenshot here, is basically, when it runs, is basically fetching the tracks for every single page. So you get like a continuous streams of pages, and in a page, you will have an array of tracks. So at this point, searching for all the songs that contain the word dark is very, very easy, because we just need to do this asynchronous loop, and then for every page, we have an array. We just need to filter that array. So very, very simple. Again, we instantiate a recent track. We do a for await. And then inside that for await, we do a for loop where we see that if basically the current track, for every single track in that page, if the track contains the word dark in the name of the track, so in the song title, then we just log that in the standard output. So this was an example use case, but was exactly the use case I want to satisfy. So this was just good enough for me. And I did run this code, and I basically started to get a lot of data. Like I had a lot of songs with the word dark in the title. And eventually I realized, oh, this is the song I was looking for. And if you look at the timestamp, it was from 8 years ago. So that's why I couldn't really remember many details about this song. Now, if you're curious, you can listen to this song. It's available online, of course. And let me know if you like it. It's a very particular style. It's kind of a jazz rock type of song. So really interesting and weird, and a little bit outside my common genre. So it was maybe also another reason why I couldn't remember this song. So that's all for this talk. If you actually want to use Last.fm, I published all of that, everything that we just discussed, as a library. You can find it on npm. And actually, this library does a little bit more. For instance, I noticed that the Last.fm API is not the most stable. Sometimes it just fails, and you just need to retry, and it's going to succeed. So this specific implementation also includes all the detecting failures and retry. So it's a little bit more robust than what we discussed so far. Feel free to check it out and check the code and let me know what you think. And with all of that being said, thank you very much for staying with me. I hope that was interesting. Definitely get in touch with me. Let me know what you think. And if you have any questions, I'll be more than happy to reply your questions. Hopefully I can, of course. Thank you very much. Bye, everyone.